An important use of regression is for making predictions, and I'm going to show you how to do that with a simple linear regression model. I'm scrolling down so you can see the content of the presentation. Alright, the data set. Well, I'm taking the data set from these guys here. We're interested in determining whether or not the amount of alcohol consumed is linearly related to muscle strength. These guys took two measurements then. They took the total lifetime consumption of alcohol, that's one variable, and the other variable was strength of the deltoid muscle in the person's non-dominant arm. Data set comes from this link here. So let's say we want to make a prediction. Now the question is, when you starting out, is what am I predicting? You need to be clear of that, otherwise it's pointless building a regression model. So let's say we want to predict, what is the predicted value of strength given the amount of consumption of alcohol. Alright, so now we've got that way around. We think about our math class. When you have a function like y equals a function of x, the x is the input, it goes along the horizontal, and y, the output, goes on the vertical of your plot. And so since our data set here, alcohol and strength, you can see there it's continuous, so I don't know what units they're talking about. We're going to do a scatterplot to see what the relationship is. Alright, I've cheated because you can see I've already done it. Just show you. So go plot. Now the plot command, the thing going along horizontal comes first, then comma, then the thing that goes on the vertical. We already said that alcohol is the input variable, so we're going to do that, comma, strength. Notice I'm not typing everything, I'm just clicking using the autocomplete command. Then I run that, and then I get this plot. And what we can see is like each dot represents a person being measured on alcohol and strength combos. And you can see there's kind of a linear relationship here. The thing is, you don't expect everybody to lie on perfectly on a line because everybody's different. That's the point of this randomness nature, even though if there's a true linear relationship between alcohol and strength. And the natural thing then to do is just have a look at the strength of the correlation. Remember, correlation is a value that takes the value between 1 to -1 inclusive. The closer it is to 1, the closer the points are to a line with a positive slope. Okay. Now for this one, it doesn't matter which order, because correlation is just like just a number between the two variables. So alcohol. I'll just tell you what you do. You copy and paste. But if you're following this, I suggest you just switch the order to convince yourself the order in correlation doesn't matter. This command. Get the negative value, correlation negative, which is consistent with this. Kind of looks like it's pointing down. This is like a negative slope of a line here, and it's 0.64. So maybe you say it's moderately negatively correlated. Right. So then, anyway, it's all pointing to trying a simple linear regression model. Now the command we need to fit a regression model is LM. LM stands for linear model. I need to give my regression object a name. I'll just call it R. Keep it short, remember, you don't have to keep typing long stuff out. LM. Now here, guys, the order matters. So the Y comes first, that's strength. I want you to notice I'm not, as above, putting the $sign, a dat $sign in front of strength for the reason I'm going to tell you in a moment. Then I put a tilde, and then I do the name of the alcohol. Oh, by the way, notice when I did that, it's got a plus here. That's good because it's kind of checking for errors as I go along. Plus there means basically I've made an error. Well, that's because I haven't even completed the command yet. Always check, guys, carefully for spelling errors. Strength. Right, why I didn't need a $sign? Because LM is very convenient because it allows us, comma, to just say data equals to the name of the data set, and then I don't have to put the $signs in front of each of those. Alright, I could have just omitted this data equals and just put dat, which is the name of my data set. Do whatever you feel comfortable with. So I've now run it, and obviously I get an error because I can see, why on earth did I do that? So X variable is alcohol. Alright, I know it's run okay this time. Why? Because I can see over in this window here where it keeps track of all the objects being created. I've got R there, right? That's the thing I've just created. Now I've created that. R is like a bin that contains a lot of information. We're going to look into that in a moment. At this stage, although I don't have to do it, I can just fit. I can superimpose on this scatter plot the actual regression line that it's estimated. I use the command AB line. Literally, AB stands for intercept, B stands for slope, like you see in your math stats class maybe. So AB line, name of the regression object, and now it's put on top this estimated line that we've estimated using this LM command. So the intercept is that, the slope is negative, consistent with negative correlation. To see the output, the summary out, we go summary R. This gets us more output than we actually need, but this is fine. Go to coefficients here, and you can see what I'm after is the estimate of the intercept and slope. So it's under here. The estimate of the intercept is 26.36. Okay, it's about here. That's right. This alcohol is negative slope, negative value. That's all right because it's consistent with the negative slope of this line here. 0.29. This number here, right? So that's the number I'm going to need for making predictions. Now going back about talking about this content in the data object, the very useful command here is names. To look inside what is in the bin there, this bin regression object creator, I go names, name of regression object, and it's telling me that I can extract all these things from inside there. What I'm going to be using today is this and that, right? So fitted values. Fitted values I might want because of this. You see, if alcohol is 10, the predicted line predicts it to be about this value. So I'm reading off the graph, but then it's very hard to know the precise values. But I can get the precise values for fitted y given x's by using the fitted command. And here I have a variation on how I use this thing here. So I can go name of my regression object, data, fitted. I could click on that, but actually if I just do fitted, that will run as well. Okay, shorthand, it's fine. Get a whole load of numbers coming out, not very useful as that is, but I'll show you how to make sense of that in a moment. Or guys, we can do it this way, fitted followed by, in brackets, name of the regression object. Does the same thing. Okay, so each of these numbers represents, a value corresponding to a value of x in the data set. If I wanted to make it more meaningful, I can actually just look at this using a plot. So plot, why don't I just plot this fitted against the actual alcohol? So that alcohol goes on the alcohol, yep, on the horizontal, and fitted, I'm going to use either of those codes, use first one, on the y. This plot, guys, you'd expect will give me exactly this line here, because that's where it is. It's plotting given values of alcohol on fitted. Let's run that. Right, what would I expect to see before I even press it? We'd expect to see that it's not a line, but it's a whole load of round circles like this, because it's like saying, where is this person was actually this, but where's the actual predicted value? It's up here. So this circle would be here, this circle would be here, and so on. So let's just run this thing. I've made an error. I made an error because I made a spelling error. Right, so there you go, alcohol. There you go. So can you see it's the same line, but it's made up of the actual observations, because you didn't have like alcohol values here. That's why there is a space here. See, it's blank here because you didn't have anything in that interval, and so on. Now I actually come back to the business end here. We want to make predictions with it. Right, so this is what a lot of businesses build regression models for. Right, predictions. Right, I can do it manually. I get hold of a calculator, because this is a form of a straight line. So I can do intercept plus the slope parameter, which is negative here, I'm pasting, times the x value for which the alcohol value for which I want the strength. So let's say let's pick a value, 15. Okay, 15 gives me a predicted value about 22. So I get that by, I can see that from the graph, it would be like 15 here, about here, go up, predicted values around, yeah, it's around here, that's fine. Instead of typing all this stuff in, the actual numbers in, or copy and paste it, we can use this coefficients thing command. Right, so again, this, like the fitted values, can be used in two ways. I could do coefficients or just coif, it will understand both. This is shorter, so can I just do this one, name of the regression object, and enter. Now it's given me the intercept and the slope coefficients. I can access them individually as follows. Say I want the first one, just the intercept. Because it comes first, it's called 1. Okay, so this is the object. I want now square brackets. I will say extract the first one, being this one. There you go. If I change this to a 2, that's going to extract out the slope. There you go. So if I want to use the coefficients, you can guess what I'm going to do. I'm just going to do intercept. Oh, can I just say before I do that, there's so that's one way. Another way is, just like for fitted, I can do this coef and say I want the first one. So this one starts with the regression object name, $sign, I extract out from the regression object the coefficient, the first one being the intercept. There you go. Use what, again, use what you like. There's no right or wrong. Although some people might think there is a right or wrong. Let's see. So this is a intercept plus. So I'm just going to repeat this line here, but just showing you what I'm going to do here. And 2, that's the slope, times the x value. Okay, I want to point out to you what I've done here. I know the slope is negative, but I have not put a negative here, notice, right? Because this coefficient is already negative. So if I put a negative here, 2 negative makes a positive. That's different to what the line actually is. So I run that and I should get the same number, right? 21.93. That works. Cool. Now I did that just to show you, how we could just access some things from the regression object. But when making predictions, actually, there's a neater way, and that's use the predict command. So let's show you how that works. It works like this: predict, name of the regression object comes first, comma, and then I've got to tell it for what values of alcohol I need it for. So I can do one of two things here. I can type list, or I can type something else, which I'll tell you about in a moment. And then I need to do an open bracket, and I've got to type in the name of the variable. For some reason I can't tell alcohol. Equals the value that I want alcohol to be set at. I want the strength for when alcohol is 15. And that looks right. There you are. Here you see, let's talk more about this command here because it's so useful. Data frame. You see, like some people say use data frame. That's fine as well. Okay, there you go. The thing about this command, it's more useful because suppose I want to calculate the strength for different values for alcohol. 15. Now let's pick a value that's not in this data set, so it shows you the thing works. That's 25. 25 is probably not, it looks like it's not in the data set. Let's stick in 25. Okay, and let's put in, say this person has a heck of a lot of alcohol. 100. So I should get 3 predicted values. And I made an error. Oh, I know I made the error. It's a good thing I did this because this is often something that often happens. Look at the brackets. I've got 1 left, 2 left, 3 left brackets. I need to have 3 closed brackets on the right. 1, 2. I missed 1. I must have just deleted by accident. Okay, so it's given me the prediction value for alcohol is 15, 25, and 100. We'll notice this is a negative strength here. More about that later. Now we're on to the next bit. It's part 8. I want to talk about predictive versus confidence intervals. Okay, so something we can get when we get the prediction is the confidence interval and the predictive interval. To do that, I go interval equals Alright, I've started, so I'll continue. I can do confidence. While I'm at it, I might as well tell you the other useful option. I can have change the levels. By default it's at 95%. Anyway, let's just set it to 90%. Okay, let's run that again. Alright, this time can you see it's giving us the low, for each prediction it's giving us the lower confidence and the upper confidence level at the 90% level. Instead of doing the confidence interval, I can do the predictive interval. Right, predictive interval, prediction interval, prediction, right, is that it? Yeah, there you go. I gotta do prediction, not predictive, right? Right. Okay, prediction. You can see I use this all the time, guys. Alright. Okay. I'm not actually interested in these numbers at the round. I'm more interested in telling you about the differences between, when would you use a predictive interval, when would you use a confidence interval for this, or can I dare say, prediction that you just calculated. Alright, the confidence interval you would report if you were interested in the question like what is the mean value of strength given that alcohol is say equal to 15. You would use a predictive interval if your question was what's the likely value of strength, what is it likely to be between when say the alcohol consumption is 15. To say it another way, for the confidence interval, this is like now interpretation of it, it's based on repeated sampling. So this thing that I've calculated, strength given alcohol, the mean value of it is a fixed number. Alright, it's not a random variable, it's fixed. So we say if we kept on collecting data on alcohol, different samples of people and alcohol and strength, and we computed confidence intervals for each sample, if we did tons and tons of these confidence intervals, each of these confidence intervals will be different because the sample values are different, because we're sampling different people from the same population though. Then if we did enough of them, loads and loads and loads of them, then the confidence, then about 95% of those will trap the true mean. That's how we interpret it. So the proportion or the percentage of these intervals will be approaching 95% as we do tons and tons of repeated sampling and tons of confidence intervals. The prediction interval, on the other hand, is saying, might be like more as you'd imagine confidence interval to be interpreted, but the predictive interval is interpreted as, you could say, okay, I'm 95 or I'm 90% sure that this interval contains the true prediction, the value given x. The predictive interval is wider than the confidence interval. Because the confidence interval, you calculate a mean, that thing I've just told you, tons and tons of confidence interval, those things like averaged out, that this mean value is average, it's like an average, this is the point value, so it's got more randomness in it. Okay, maybe I should have left that point to the end, because probably you don't need to know that exactly. This last point is probably more important for newbies. Right, extrapolation is when we're using the model to make predictions outside the range of the input data and should be used very cautiously, avoided if possible. Right, so I showed you earlier when we predicted the strength when alcohol consumption was 15, 25, 100. 15 we can read off the graph, 15 is in the data, yeah? 25 is in the data. 100 isn't in the data, it's out of the sample, it's off the graph. This says the strength is negative. Well, that doesn't seem to make sense because you think the strength can't be less than 0. I mean, okay. So why what we've done here is extrapolation, because this 100 is not in the interval, in the sample of the x. And that's dangerous because who's to say this pattern continues in both ways as a straight linear line? In other words, the regression only describes what's happening in the sample of the x range here, for alcohol. And when you pretend that this pattern continues outside the range, that's called extrapolation. Now, if you extrapolate just a little beyond it, then okay, there's some reason to be okay with that. But if you extrapolate far out, that's totally, you imagine, not okay. All right, so that's a flavor of prediction.